You write out the title today, Two Fundamental Theorems of Calculus and Some Methods for Computing Definite Integral. Okay? Now you write out the title. Okay, now one. The two fundamental theorems of calculus. Before we comment two fundamental theorems of calculus, we have some related theorem. Now you write out the theorem. The first theorem, if the f integrable on floatable AB, then the function f defined by integral from the A to X activity, the function here, all the way well defined and continuous on AB. In addition, if the function f continuous at AB, if the function f continuous at AB, then capital F differentiable at actual. Okay, the two things here, you can prove directly. But we ignore the process. In this content, I want to recommend two fundamental theorems. Okay, based on the fourth term here, you can imply the first fundamental term. In that way, you can use the antiderivative to compute definite integral. Now, let's see. Let's see the first fundamental term. First fundamental term. Okay, we can do the Newton-Leibniz formula. Now, we can see the content of theorem. If the function f continuous on the floatable AB, f is the antiderivative of fx, then we can find definite integral. You can find definite integral from the A to B fx here is equal FB minus FA. Okay, wait a minute. Okay, yes. First fundamental, if the x is continuous on global AB, and ax anti-individual function f, then you can find definite integral f from the A to B is equal AB minus AF.
Như quả áo vậy đẩy xong lên chỗ áo mới muốn nghỉ từ trước rồi. Chi những cái tiếp là ngân hàng đúng không? Mình thấy
Okay. Now we can prove the first fundamental theorem is well. Now let's see. F anti-derivative function f. Now written here, you can see the capital F anti-derivative. I think you know two anti-derivative function f all the way have a different constraint. Okay? So we have the ax is equal capital Fx plus c plus c. Now, from here we have the fb minus fi. Finally, is equal fb minus fi. Okay, I think you can see the fb is, I mean, we can replace the f by b. A to b ft dt minus aa ft dt. Given here is equals 0, okay, in here it equals 2. Okay, so we can estimate definite integral is based on the antiderivative. Okay, now let me give you an example. We apply the first fundamental theorem using the formula to compute definite integral. Now let me example. Compute the definite integral. Integral from the 0 to 1 x squared dx. Okay, in this example, we want to apply first fundamental theorem to estimate the definite interval here. Okay, I think if you want to apply the first fundamental theorem here, I think we need to check the function f satisfy the condition. Satisfy the condition of the theorem. Now, you can see in this example here, the function f integral is equal to x squared. Okay, x squared. I think the function f equal to x squared continuous on global interval 0 to 1. Okay, so the condition for first fundamental theorem satisfied. Okay, satisfied. Now let's see the solution one. Now, the first of all, we check the condition. We check the condition for the fundamental theorem. For fundamental theorem, you can see the function f continuous on global interval AB. To continue, very easy to see the capital F is equal FQ over 3 anti-derivative function f. Okay? Very easy to see. To continue, using intergrals formula, we can obtain definite integral from 0 to 1, s squared dx is equal anti-derivative from 0 to 1. Okay? We replace f by 1, replace f by 0. Okay? It equals 1 cube over 3 minus 0 cube over 3. Okay? The final result 1/3. Okay? The first solution here, we use first fundamental theorem. In this example, we always check condition. Always check condition of first fundamental. But when you do the exercise, you can ignore that. Okay? We only use Newton leveling formula directly. You don't need to check this condition. Okay? You can ignore that. Brief solution. In this solution, we apply the formula directly and only checking the condition in formula. Is that we ignore the condition. Brief solution lời giải ngắn gọn. Khi các bạn làm, các bạn có thể bỏ qua cái chỉ điều kiện. Okay. This line enough for the solution. Okay? We can estimate definite interval here by only one line. It's by on first fundamental theorem. It's by on the Newton leveling formula. Okay? Only one line. Okay? Only one line. You can ignore checking the condition. Sau này thì các bạn một là các bạn dùng first fundamental theorem, hai là các bạn phải gọi công thức đấy là công thức Newton leveling formula nhé. Có thể gọi vào một trong hai tên, một là bạn gọi là định lý cơ bản đầu tiên của giải tích, hoặc là các bạn có thể gọi đó là công thức Newton leveling. Thì thường thì hay dùng công thức thường dùng tên gọi là Newton leveling hơn nhé. việc tên nào cũng được. Okay. Now continue. I give you the other example. Now we want you the Newton limit to find the limit. Now let's see. Express the following limits in terms of f integral. Then compute the limit. Then compute the limit. Previous lesson, we only express the limits by f integral. Okay? Is it simple? Is it simple? We need to compute the limit. We compute the limit here is by our Newton limit formula. The first, we can express the limit by definite integral. The second, we use Newton limit to find the limit. Okay, so seven. Okay, I think you know the idea for those process, the idea for. If you want to express the limit here by definite integral, what do we need to do? We need to use the first formula and second formula to get to definite integral. Okay? It's by out the formula. Now let's see. It's by out the formula. Okay? We need to choose a Gaussian f at interval. Okay? Now, how to choose a Gaussian f at interval AB? I think we need to compare. We need to compare two formulas here. Okay? This may be you can guess the f A and B. We need to compare. Now, how to find the function f A and B. Now, perhaps when we express the expression here by sigma notation, we compare. Now, we compare two formulas here. This may be we can get b minus a equal 1. Okay, it may be 1 b minus a. Okay, so we get this may be b minus a equal 1. Okay, now b minus a equal 1. We have a lot of AB. This may be we can choose. Now we check. This may be you can choose the a equal 0, b equal 1. This may be we can get fx. Now, if we choose the a equal 0, b equal 1. Okay, the value here it becomes f k over n. Okay, so the value here when we take the a equal 0, b equal 1. Okay, we have value here is become. So value here is maybe it equal. Okay, it may be it equal. It equals square root 1 plus k over n. Now let's see. The value here is equal value here. So we can guess fx is equal square root 1 plus n. Okay? Now, the different example. In that case, we choose the a equal 0, b equal 1. This may be we can choose the a equal 1, b equal 2. Okay? Now, try some example. I have 1, B equal 2. Okay. Now we need to get the function f. When we replace a equal 1, b equal 2, the value here is become 1 plus k over n. Okay? 1 plus k over n is equal square root 1 plus k over n. You can see two values here is the same. So we can get in this case the function f is equal square root f. Okay? It's square on the AB. We can get the f. Okay? And you understand how to find the AB and f? Okay? Compare. Now, it returns to solution. Okay. Now, based on the formula, the first we derive the presentation here by sigma notation. We compare two formula here. Okay, we can obtain. Okay, this may be we can choose the specific. We can choose the a equals 0, b equals 1. Okay, we have the function f corresponding. Okay, the function f is therefore square root 1 plus f. Okay, you can write down before we continue. Okay, continue. When we know the A, B, and M, okay, exactly we can express the ball limit by definite integral. Okay, and we have the limit here is equal definite integral from 0 to 1 square root 1 plus m here. To continue, you base on the Newton-Frederick formula. Okay, you base on the antiderivative. We can compute definite integral by this 1 plus x the power 3 seconds over 3 seconds. Okay, x value from 0 to 1. We replace x by 1 and 0. We obtain the result of this integral. equal 2 times square root x minus 1. Okay, you can do that now. Okay, now continue relation to the second fundamental theorem. Okay, the second fundamental theorem. Now, let's see the content of this theorem. If the f continuous and x differentiable on the open interval AB, then the function z defined by definite integral from the a to a activity. The function here is well-defined, differentiable, and we can compute the derivative function z equal f at gx dx times the x round x for all x belong to AB. Okay, we can prove the theorem here directly. Okay, but I don't listen to how to prove that. Okay? Okay, now continue. Okay, if I on the second fundamental theorem, we have the extent theorem. Listen to the corollary. The function z has two limits u and s depends on x. We have the diagram is equal. The corollary is we can prove is on the second fundamental theorem. have the difference is equal the value function f as hx have a prime minus the value function f as t equal uf times the e prime f.